Hello everyone. In this video, we are going to discuss about atomic mass and average atomic mass. You see, after having some idea about the terms atoms and molecules, now it is appropriate to understand what do we mean by atomic masses and why we are taking average atomic mass. You see, let us see what is an atomic mass. See, atomic mass means mass of an atom. At present, system of atomic masses, it is based on carbon 12 as the standard. You see, carbon 12 is one of the isotopes of carbon. It is represented as C612. No, it is represented as like this, carbon 12. See, carbon 12 is assigned a mass of exactly 12 atomic mass unit, AMU atomic mass unit, and masses of all other atoms are given relative to this standard. You see, one AMU is defined as a mass exactly equal to 1/12 of the mass of one carbon atom. That is, one AMU equals 1/12 the mass of one carbon 12 atom. That is, suppose this yellow colored one, no, suppose this one from this end to this end, the whole part is actually one carbon 12 atom. Suppose this is one carbon 12 atom. Okay, that is we are considering one carbon 12 atom. Now, if we divide this into 12 equal parts, 1, 2, 3, 4, 5, 6, okay, 12 equal parts, then the mass of one part of this carbon 12 atom, that will be 1 AMU. And when you calculate the mass of, one part of this carbon 12 atom, that is 1 AMU, that will be equal to 1.66056 into 10 raised to minus 24 gram. So 1 AMU equals 1.66056 into 10 raised to minus 24 gram. That is, this much grams together is considered as 1 AMU. So you see, 1 AMU, 1 atomic mass unit, that is actually equal to 1.66056 into 10 raised to minus 24 gram. Now let us see what will be the mass of one hydrogen atom in AMU. You see, actually the mass of one hydrogen atom in grams, that is actually 1.6736 into 10 raised to minus 24 gram. Okay, then you see here we have 1.66056 into 10 raised to minus 24 gram is actually 1 AMU. From this you can write 1 gram as 1 AMU divided by, when you take this to this side, goes to the denominator. So 1.66056 into 10 raised to minus 24 in the denominator. So 1 gram is equal to this much AMU. Then what about our mass of hydrogen atom, which is 1.6736 into 10 raised to minus 24 gram. 1 gram is this much AMU. So 1.6736 into 10 raised to minus 24 gram will be 1.6736 into 10 raised to minus 24 into 1 AMU divided by 1.66056 into 10 raised to minus 24. Just mathematics. Okay, so this into this. Okay, 1.6736 into 10 raised to minus 24 AMU divided by 1.66056 into 10 raised to minus 24. When you do this calculation, 10 raised to minus 24, 10 raised to minus 24 cancels, and you will have 1.6736 divided by 1.66056. When you do this calculation, you will be getting it as 1.0078 this much AMU. That is, mass of one hydrogen atom is 1.0078 AMU, or you can round off this into 1.008 or 1.0080 AMU. That is, what you want to understand is, the mass of one hydrogen atom in AMU is 1.008 or 1.0080 AMU. Okay, mass of an hydrogen atom in grams is 1.6736 into 10 raised to minus 24 gram. In AMU, it is 1.008 AMU. Okay, similarly, if you find out the mass of one oxygen atom, you will get it as 15.995 AMU, or you can approximate that into 16 AMU. Okay, you see, at present, AMU that has been replaced by U. Okay, AMU atomic mass unit, this is replaced by the letter U which is unified mass. So either you can write AMU or U. So U also means AMU, which is unified mass here. Okay. Now let us talk about average atomic mass. You see, many naturally occurring elements exist as more than one isotope. What is an isotope? See, the isotope will have same atomic number, different mass number. Okay, that is many naturally occurring elements, they have different isotopes. That is, for example, if we consider hydrogen, the isotopes of hydrogen are H11, H12, H13, that is protium, deuterium and tritium. Tritium or tritium. Okay, here you see the atomic numbers are the same, but they differ in mass number. Same atomic number, so same elements. Okay, hydrogen, 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 but different mass number. That is actually called as isotopes. Okay, similarly, if we consider chlorine, the isotopes of chlorine are Cl1735 and Cl1737. You see same atomic number, different mass number. And similarly, if you consider the isotopes of carbon, you see we have three isotopes, naturally occurring isotopes. One is C612, then C613, C614. You see same atomic number, different mass number. So many naturally occurring elements, they have more than one isotope. That is, the atomic masses of isotopes are different and they exist in different proportion in abundance, which means that some isotopes are more naturally abundant on earth than others. The relative abundance of each isotope can be determined by using mass spectrometry. So anyway, when we use atomic masses of elements in calculations, we actually use the average atomic masses of elements. That is, when we consider chlorine, it has two isotopes present in our nature. So when we talk about the atomic mass of chlorine, we will take the average atomic masses. For example, see, carbon has these three isotopes and their relative abundances and masses are also shown here. You see for C612, its relative abundance given in percentage, that you see 98.892%. Atomic mass in AMU, 12 AMU or 12U. Okay, because AMU is actually taken as one unified mass. Similarly, C13, then C14, their relative abundance and atomic mass are shown here. And from this, it is very clear that C612 isotope of carbon, that is actually plenty in nature with an abundance of 98.892%. Now, let us see. Anyway, you see, when we talk about the atomic mass of carbon, there are three isotopes naturally present, present in our nature. So, we have to consider all the three when we talk about the atomic mass of carbon. That is why we are taking average atomic mass. So, in general, to calculate the average atomic mass of any element, we can use this equation. Atomic mass of one isotope into its abundance plus atomic mass of another isotope into its abundance plus atomic mass of the another isotope into its abundance plus etc. Okay, all divided by 100. So here, how can we calculate the average atomic mass of carbon? See, average atomic mass of carbon is equal to atomic mass of one isotope. So C12 isotope, it has atomic mass 12U. So 12U into its abundance that is 98.892% plus atomic mass of another isotope. So C13, its atomic mass is 13.00335U into its abundance, that is 1.108. Okay, plus we have one more isotope here. So atomic mass of the third isotope, which is 14.00317 into its abundance, which is 2 into this much U into 2 into 10 raised to minus 10. Okay, whole divided by 100. Now, This can be written as 12 into 98.892 U. Okay, see this divided by 100, this denominator is common for all the three terms, no? So, divided by 100 plus 13.00335 into 1.108 U divided by 100. Okay, plus 14.00317 into 2 into 10 raised to minus 10. Okay, U divided by 100. That is, we can split this into like this, because 100 is a common denominator. We can write like this. Alright, now this will be equal to 12 into 98.892 divided by 100 will be what? 0.98892 U. Okay, or 12 U into this plus then 13.00335 into 1.108 divided by 100 will be what? 0.01108 U. Okay, plus 14.00317 into 2 into 10 raised to minus 10 divided by 100. So 100 is actually 10 square. When you take it to the numerator, it becomes 10 raised to minus 2. Okay, so 10 raised to minus 2 into 10 raised to minus 10 will be 10 raised to minus 12. So this will be 2 into 10 raised to minus 12 U. Alright. And when you do this calculation, you will get it as almost 12.011 U. So average atomic mass of carbon is 12.011 U. U means AMU or U, unified mass. Okay, so this is how the average atomic mass of carbon is found out. So in this video, we have discussed about atomic mass and average atomic mass. I hope it is clear to you. We will be discussing about the molecular mass and formula mass in the coming videos, which will be available in the playlist. Thank you.